So it turns out that the numbers that we have so far, the whole numbers and the natural numbers, are not enough to do everything that we want numbers to do. Why not? Well, one of the things that we want numbers to do for us is to tell us the difference between two values. For example, suppose I tell you that yesterday I had $7 and today I have $9. What's the difference between what I had yesterday and what I have today? Now, a little bit of thought will tell us that subtraction is what I want to use to model this. What do I mean by model? When I talk about modeling something, I just mean to describe it mathematically. I mathematically describe this question by using subtraction. Right? I take what I have now minus what I had then, and I get the difference. Right? How do I understand this? I got $2 extra. In general, we will model a difference or a change by saying the final or ending value minus the starting value. So if something is changing with time, we take the value at the later time minus the value at the earlier time. And that certainly makes sense in this story, right? What's the difference between yesterday and today? Well, it's how much more I have today than what I had yesterday. But this creates a problem. What if yesterday I had $9, but today I have $7? That's certainly something we can imagine happening, right? And of course, we know what happened. What happened was I spent $2, right? But our model breaks down. 7 minus 9 is impossible in the whole numbers. No whole number is the answer to 9 plus what equals 7. The solution, of course, is that we need some new numbers. We need some number to be the answer to 9 plus what equals 7. Well, remember how we answered questions about addition and subtraction earlier? The object model seems kind of funky. Let's think in terms of the vector model. If we wanted to draw a picture of 9 minus 7, right? Of course, we know that 9 minus 7 is 2. Well, we would look at this picture of the vector 7 and a picture of the vector 9, and we would say, what do we need to add on to the end of 7 to get out to 9? Well, this is the vector we need. Let's pick it up and see what number this is. Oh. And of course, as we already knew, that's the number 2. Let's draw the same picture, but now for 7 minus 9. Right, again, we're saying 9 plus what will give me 7. We know that no whole number does this, but we're going to try to get a vector that does it, so we can at least see what it looks like. So we'll draw our vector 9, and we want to know what we need to add on to the end of that to get our vector 7. Well, just looking at the picture, we see that it's going to have to be something that goes to the left. So we start out here at the end of 9. We go to the left, and we get to the end of 7. This vector, whatever it is our answer to 7 minus 9. All the whole numbers go off to the right. How the heck am I going to get some numbers to go to the left? We need some new numbers. we're going to need some brand new numbers to describe the vectors that go to the left, and we're going to introduce them in our next video.